Hello everyone, welcome to Computer Science E76. This is Lecture 3, Android. So today is when we really start getting into the Android SDK. And so today what we're going to talk about is a bit about Eclipse itself, how you can actually download the SDK and get it all up and running. We'll also create our first Hello World application and do a variety of things, including talking about how we can debug some of the applications. There's some nice debugging tools that are included both with the SDK and with Eclipse as well. And we'll go over some other related things like that. And one of the first things that we'll talk about with regard to development for Android specifically, something called activities and views. And we'll talk about what that means in just a short while. So, first, some initial information. So as you know, you've seen this slide a couple of times by now, and this is going to become your friend as you start working on the Android projects. Not only the setup project, but also the staff's choice, and then followed ultimately by the student's choice project in the Android section. You will use this website quite a bit, and there's a lot of references that are available here. If you are unsure about something, before you actually start asking questions, take a look on the developer site to see if there's something obvious that might come up. There's a lot of things that can be answered on the developer site, and they continuously are adding to their documents. In fact, it is moving quickly enough that I will say that it is useful and you should check it out, but some of the documents are also a little out of date. Some of them do reference older versions as well. So if you do happen to find some data on there or some information, and it's not quite what you expect or it's not quite what you're seeing, then that's certainly a good time to start asking us questions on the help board as well. So Android, as we talked about a little bit in the first lecture, it runs on a modified Linux platform, and we code in Java, and we do compile it into some bytecode that is ultimately converted not to Java bytecode, not to the standard JVM bytecode that we might be accustomed to in other Java development, or like we saw last week in the Java primer, but instead there's an additional step that has to happen that converts this Java bytecode to a Dalvik bytecode that is then packaged up and created into a nice Android application file, and it is that application file that we can then install on the device itself. And so I just want to mention a couple of things. There are two development kits that are available on the developer website. One of them is the software development kit, the SDK. There's another one called the native development kit, the NDK. We're not going to be touching the NDK at all in this semester, so I would not even bother downloading that unless you really have a good idea what you want to do and you know that you can actually use it to your advantage, perhaps for your student's choice project. So the SDK is really going to be the focus of the next few weeks as we talk about Android development. So how then can we actually create an Android application? Well, the basic steps are numerous. There are a few things that we have to do in order to go from our source code to a final APK file. An APK file is just the extension that's given to an Android package that allows us to install that onto a device and actually use it as an application on that device. So as we mentioned before, you write your application in Java using some in just standard Java source code files. Then you compile that using the typical Java-C compiler like we've seen last week. And then it starts to diverge a little bit from what we saw last week. You then use a separate tool called DX, which converts that Java bytecode into that bytecode that is then interpreted by the Dalvik virtual machine. So that DX step is really what takes that original Java source code, or rather the original Java bytecode, and does some things to it to optimize it a little bit for mobile devices and for their use ultimately on the Android device. And then we get, as a result of that, a DEX file, or Dalvik executable. Then we package that up with a bunch of other files, including any resources, like we might want to include some images or some sounds with our application. We might have some XML files that define layout or some other things, and there's a couple of required files that are actually you must include in addition to your .dex executable file. Zip that all up into an APK file that you can then install onto your device. Now there's something that's interesting about this APK file. It really is just an optimized zip file. So if you happen to get access to an APK file on your computer, what you can do is rename that file as .zip, and open it, and it will actually decompress as a standard zip file, and you can actually see the construction. Of course, what you will see is the compiled version. You're not actually going to see the source code for that, but this is a way that if you were curious about an application that you would be able to peek into its contents. And by the way, I'm acknowledging this now because I know that when we release the staff's choice, we're also going to be releasing an APK file with the sample solution. And we will know if you dive into that file to find out how we actually implemented it on our end. So just beware that we are fully aware that this is doable and it's something that some people like to do. Now, normally, if you are actually going to write Android code or Android applications with a standard text editor and then compile it, these are all the steps that you would have to do. But luckily, all of this stuff is abstracted away with us through the technology or the application that we're using called Eclipse. So Eclipse is an integrated development environment that's not written specifically for Android. It's in fact separate from this entire process of developing Android applications, but it's something that we can use to by installing an Android plugin and installing the Android SDK and use that to abstract all of those additional steps so that all we have to do is use this IDE, write our source code, click a few buttons, and all of a sudden we go from our Java source code to a final APK file that we can either distribute or debug or install locally or what have you. So Eclipse is going to make this a little bit easier for us. And so just to curb any of these questions now, yes, you do have to use Eclipse because when we actually accept project files from you, we are expecting them to be in the format that Eclipse will export, just to make it easier for us to be able to look at all of the projects at once, and so that we don't have to go from one IDE to another, even if the TFs happen to have some other IDE available. This is the best way, this is the best supported way to create an Android application. So there's a couple of steps when you want to get started with developing Android applications. First of all, you have to download Eclipse. You should download the Eclipse Classic version. All of this is documented in the setup PDF. Download the Eclipse Classic version, the latest one, and that is appropriate for your architecture, whether it be 32 or 64-bit. But that's not enough. You also have to download the Android SDK itself. But even that is not enough. Once you download the Android SDK, you also have to download and install a plugin that connects that SDK to Eclipse so that Eclipse can actually see the SDK. So there's that ADT plugin as well. So far that's 3 things you have to download, and really that's kind of it. Once you download those and install those as appropriate, as we demonstrate, or as we talk about in the project specification, and it's also pretty well documented on the developer site as well, then you're pretty much done actually doing the manual process of downloading things. From there, Eclipse will try to help you out to download some additional things, but realize that the SDK itself does not actually include a lot of the packages that are required for building applications towards specific versions of the Android OS. So there's yet still something else that you have to download, but you download this within the context of the Android SDK. So you might see this window, and this is going to be something that you're going to be seeing a lot of, especially at first as you get all of this set up. This is called the Android SDK Manager. And again, I sort of glossed or I didn't even show you how we open this up, but it's something that will come up when you first install Eclipse and install the ADT plugin and the SDK. This will come up and allow you to download some platforms that you can then use to build your application. What I basically recommend, if you really want to, you can install everything, but frankly that's going to take forever. It's gigabytes worth of stuff here, because most notably some of the stuff that takes up a lot of space are some of these images that are specific images to various hardware devices. You don't really need to worry about these so much. What you do need to download though is in fact let's see, where are they? The SDK packages available from Google. And so what I recommend is to sort by repository, as you can see here, and then look for all of the Google repositories, which you can see it's Google because it's just in the domain name there. Whoops. It's just in the domain. Basically just install all of those. And if you are unsure, the main ones that we are really going to need are these, called SDK Platform, Android, and then the version number. It's really these that you're going to need installed. But if you want to go all out and install all of them, that's fine. It's all free. You don't have to worry about any of that. All right, so once you have all of that stuff installed, then you can actually start to use it to create and develop an Android application. But I do want to point out a couple of important things. First of all, there's a lot of stuff that's downloaded. And in the SDK itself, there are a variety of tools that are provided to you, some of which are abstracted away in Eclipse so that you can actually access them from Eclipse. But some of them you might actually want to be able to run directly, as you'll see why in just a few moments. And so this is an older version of the platform, of the SDK rather, and so there's some differences, there's some minor differences here, but basically what you're seeing is just a subset of all of the tools that are available in the Android SDK. Now, some of the important ones that I want to point out, these are all applications. One is called Android, which is just the SDK manager. That's that application that you just saw a moment ago where I could download additional packages and use them in my in Eclipse or to build Android APK files against. And then there's also one called DDMS, something that you'll actually use within the context of Eclipse, but you can also use directly as well, and that's used to debug a variety of, it provides a variety of debug tools that are useful when we are actually taking a look at some of these applications. Some other ones, there's an emulator. That's actually the application that's responsible for creating AVDs, which are Android virtual devices, and running them as well. And then SQLite 3, which we will actually take a look at the very end of all of our discussion about Android. But it's a way that you can manage SQLite databases on a device, or more specifically on an emulator, from your own terminal window. Now, when we take a look at an emulator, so before, if you use an older, if you happen to do any Android development before, say older than about 6 months ago or so, things have changed in that time. And before, all of this stuff used to be in one window. And what I mean by all of this stuff is this window right here, the Android Virtual Device Manager, and also that previous window that we saw just a minute ago, the Android SDK Manager. So if you happen to have taken a look at this before and haven't looked at it quite yet, just realize that these are now split. But the Android Virtual Device Manager is the way that you will be able to create these emulated devices, these emulated Android devices. You can create multiple ones of them. You can run multiple of them. And you can manage them all from this window. So notice that I have a few that I have created here, all in varying version numbers of Android with varying names and different platforms and API levels. So each of these are basically just emulators that you can create very easily. So when you click on New, you can actually provide a name to that Android virtual device. I just like to give it something that I will be able to easily identify. Perhaps one of the things that you might want to include is the version number of Android, any special hardware features that you provide to it, because you can, in fact, have multiple AVDs that are of the same version number, but include different hardware features as well. As you'll see that we can actually emulate a variety of different aspects of the hardware device just by adding some support. That's possible here. So if you happen to have an application that uses one of these features, you can create multiple AVDs that either have these features enabled or do not, and you can see how your application behaves in each of those contexts. Now, but for most of the stuff that we're doing, especially the lecture examples that you're going to see, you don't really have to add any of these special hardware features. Basically, just the default version or the default hardware features is fine, and you can just, all you need to do is provide a name to it, like ICS for ice cream sandwich, and then provide a target, which is the version that you want. Notice that we have a couple of different things for different API levels. The API level is basically just the developer version that we're taking a look at. The API level basically means which APIs are available in different versions of Android. It just so happens that as we increment the version of Android, the API level goes up by 1, as you can see here. But generally, when you create an AVD, you don't want to use these Google APIs that you see here. You will, in fact, just use one of the Android versions. So just pick one of these Android versions, then you will create that, let's see, ICS 4.0, then you can create that IVD. And so notice that when I selected that, it did have some default hardware specs that I could either choose to modify or not. So when I click Create, we can see that it is now in my list here. Now, when you want to start an emulator, you can either do it directly as you're working on your application. You'll notice I'll show you what I mean by that. Or another thing you can do is you can just start it directly from this AVD manager. When you click Start, I'm not going to do it now because what happens is that it just takes, honestly, quite a long time for an emulator to start. This one took probably about 5 or 7 minutes to start on my machine, and so I did it before class. But this is what it looks like. Oh, I should actually probably click Start because one thing does appear. That is the launch options window. Now, typically when you are starting an Android virtual device that is of a newer version, particularly the 3.0 versions or the 4.0 versions, those have enormous screens that if you just start them normally without scaling the screen, it is going to be larger, most likely, than the window that you're actually using or than the screen that you're actually using to look at that emulated device. So I recommend if the first time you start it, it looks like it's an enormous screen, actually scale the display to a real size. So the very first thing you need to do is calculate your monitor DPI, which makes it very easy. You just tell this little pull down what screen size you're using. In this case, it's a 13-inch screen and happens to know the resolution, so it can calculate the monitor DPI very easily. And then you can give it a raw size the inches that you want. So on my 13-inch screen, I've noticed that something around 6 inches is kind of ideal, is kind of the ideal size. It's a little bit smaller to actually show up on the projector here, but you'll have to play around with that as you work on your emulators. So anyway, once you get all that up and running, then you actually have this emulated device. You can actually use this device as if it were an Android device, subject, of course, to the limitations that we talked about in the emulator. And you can also send your applications, your projects, as they are compiled to different emulators. So you can have multiple emulators running. You can run your application on each of them and compare and contrast how it works on each one. I will warn you that this stuff is a bit of a memory hog, so take care when you're running this stuff. And one of the things that I do recommend is once you open an emulator, don't close it in a session as you're actually working on it. Some people, what they do is they will actually they'll be coding along in Eclipse, and then they'll hit the run button to compile it and send it to an emulator, and then they'll wait for the emulator to come up, and then they'll see their application. Then what they'll do is they'll close the emulator and then go through this whole process all over again. They'll make whatever changes in their source code, and then the whole thing will have to happen all over again. You can just leave the emulator running, and as you make changes to your code and hit run, it won't have to reboot the emulator. It will just send that new APK to the emulator and run it like that. So keep it open, because that will save you some frustration. Did I see a question before? No. Okay. All right. So that is emulated devices. And of course, the limitations that we mentioned before are some obvious things. You can't actually place any calls because there's no network connection. There's no, by network I mean cellular connection. There's no support for USB connections. There's no real support for cameras and this sort of thing. For this, if you have a project that uses one of these features, you very well likely will need to test it on an actual physical Android device, just because otherwise you're not going to be able to fully support or fully test your application without subject to the limitations of the emulated device. Now, it is in fact possible to run your applications directly onto a hardware device. In fact, that's what you're going to see me doing, and I'll talk a little bit more about that as well, so that you can actually choose. You can have multiple Android devices connected to your machine, multiple emulators running, and choose which of those devices your application is going to be compiled and sent to and run. And that's actually a really neat and handy thing as you're working on a project. Now, all of these tools are pretty agnostic in terms of the version, the Android version number that we're actually using. So these are just called the tools. But there's also another series of tools called the platform tools, and these happen to be updated every time there's a new version of the Android SDK, or rather the Android platform that is then updated, because they will support the newer version. They will also be backwards compatible to some older versions as well. Now, some of these might look a little bit familiar, and by some I mean one really. This DX converter at the very bottom, that was, if you recall, that application that takes the Java bytecode, the precompiled Java bytecode, and converts it to the Dalvik executable bytecode. And so that is very useful for us. But again, Eclipse abstracts that away. Just notice that that is actually an application that exists in the platform tools, but we don't have to directly run it in the context of this course. But some of them are pretty useful. I think one of the tools that you will use the most of all of these is, in fact, this one at the top, ADB, or the Android Debug Bridge. And this tool actually allows you to communicate directly with an emulated or a physical device to be able to install applications, or you can pull or push files to from the devices. You can query the log files on each of these devices. You can actually initiate a shell and be able to run arbitrary Linux commands on each of these devices. And so it's a very useful thing that we're actually going to be using quite a bit. And I'll show you an example of that in just a moment. Now, there is one thing that I want to point out with regard to this emulated device, and that is the title bar at the very top of this window. Notice that it has a number up there, 5554:ICS. If you recall, ICS is just the name that I've provided this AVD, but what I want to draw your attention to is that number. This number refers to the port number of this emulator on your local computer. And as you open up additional ports, or rather as you open up additional emulators, that number will increment by 2. So if I were to open up another emulated device, that number would go to 5556 on that new emulated device. And that port is actually very useful and it's very handy because what it allows you to do is to telnet in to that emulator and provide even more functionality to that emulated device. So I said before that you can't actually place calls. Of course, you can't do that because there's no sense of the cellular connection or what have you, but you can use that to simulate placing calls. So you can simulate in the emulated device that it's receiving a call or that it's receiving a text message or that some state has actually changed in that emulated device. So how then can we actually do this? This is actually something that's pretty neat, I think. So let's say that we have here just open up a terminal window. This works on Mac, on Windows, on Linux, anything that has the Telnet tool available. What you want to do is telnet to the local host, which is your own computer, and type in that port number that's in the title bar of the emulated device that you want to connect to. So in this case, it's 5554. So I'll hit return. We'll see that it says OK at the very end down here. And the very first thing that you should do, unless you know specifically what you want to run, is type help. And it shows you a list of commands that you can actually run on this emulated device. And some of them are pretty cool. For example, power. We could simulate various power things. So if I wanted to, for example, check out what sorts of things we can do in power, well, let's see. I want to set the battery status. Let's see, help power status to not, let's say that it's full. So let's do power status full. It says OK. And up here, hopefully pretty soon in the device, it will actually say that it is full, but it looks like it's not doing that. All right, let's do something else. I think one of the better demos is, in fact, sending a text message to it, which is pretty cool. So SMS send, and then I think I have to type in a phone number. Hello, world. I probably have to put it in quotes. Let's see if this works. It says OK. Eventually, it says, hello world. As you can see, I received a text message on this emulated device. So you can simulate, and even some more complicated things as well. I believe you can actually even send some kernel messages to it. There's some pretty neat things that you can do with this option here, with this telnetting into the emulated device. It's a pretty neat thing and something that you should take a look at. And you will also be able to do a variety of things like geo-related things. So if you actually were creating a geo mapping app of some kind, or some app that relies on the geolocation of the user. Of course, in an emulated device, it's going to be very difficult to actually use in GPS. So you could set some arbitrary GPS points here, and I'll actually show you there's a way in Eclipse as well that you can create a track of GPS coordinates so that your application would then be able to follow. And there's a whole bunch of stuff that's pretty useful and interesting there. Now, as we saw just a moment ago when we were looking at all of the various versions that are available and the platforms, all the various platforms that are available for us to download and install, there are a lot of versions. And this is something that we should address up front. There's a lot of different versions of Android that are installed on a lot of different types of devices. And this is something that is difficult for us to reconcile. It's something that Google claims to be working on, this hardware, or rather this fragmentation of the Android OS. But frankly, it's still kind of a bit of a mess in terms of how many different versions of the Android OS that we have to support, how many different types of hardware we have to support, and as you'll see in a moment, how many different types of even just the screens that we have to support. So right now, this was the breakdown of versions that I showed you from a few weeks ago. And as we can see, the vast majority, the biggest part of the pie is Android 2.3.3, which is nice because we know, okay, well, if we target then an application for that version of the Android OS, we can get the majority, over 50% of the users that are using Android devices. But it has changed slightly since then, ever so slightly. And so now it still is the case that Android 2.3 is the primary version, but it's in fact a little bit larger. So it's now almost 60% of the installed versions of Android happen to be version 2.3. And the latest version, 4.0, or 4.0.3, there's only about 1% right now of the Android devices in use are actually using the latest version of the Android OS. And this is due in part by the fact that when new Android OS versions are available, they can't always be backported to the original hardware devices. Sometimes the manufacturers have created some additional skins or some additional programs or applications that are specific to that phone, and so they install this on top of the Android OS, and so what they have to do is then update all of that stuff for the newest version of the Android OS. This can take some of them months, could take some of them years, and some of them just give up and don't do it, which means that some hardware mobile phones cannot actually run the latest versions of the OS, even though they might be physically capable of doing it. It's just sort of a political, or rather maybe perhaps a business decision where that's the case. So as we can see here, the smallest portions of the Pi are the very newest versions, 4.0, 4.0.3, and the very oldest versions, Android 1.5 and 1.6. So there are, in fact, some people that are still using the ancient Android G1, that original one from many, many years ago. So what we are going to do, and you should sort of be thankful that we're doing this year. In years past, we always require that people target applications in the oldest one possible, and for most applications, that meant Android 1.5. Now what we're going to be doing is targeting the version 2.0, and that will not only cover the vast majority of the users, but it's also, frankly, going to make your lives a lot easier as you start coding for these applications. Now, it's interesting to see this platform version change over time. This graph is actually just taken directly from the Android developer site. I recommend you take a look at that. Every couple of weeks they update it, and it's neat to see what the latest versions are. But it's sort of predictable, I think, how the progression of these versions actually occurs. Now, they do also provide some additional information as well, most specifically regarding the screen size of these devices. And so this is what it used to look like. This is the distribution of screen sizes and screen densities from July 2010, when there weren't still that many Android devices out, and all of them were in fact phones. Now of course we have tablets and all sorts of stuff, but we can actually see that the vast majority of the Pi are in fact for screens that are normal sized and either a high DPI or a medium DPI. And so the high DPI is at the top, which is very close to 50%. And the medium DPI is on the bottom, which is just below 50%. And then the other screens were small ones with low DPI or what have you. Now, because there's so many more devices out there, this is what the Pi looks like nowadays. So most of the devices that are using Android are still have a normal size screen. And a normal size screen in this context refers to the size of the I suppose a standard Android or standard smartphone size screen. But then we can also see that we have other sizes like extra large and large, which might be on some devices like tablets and that sort of thing. So we do have to support then some additional hardware features in our own applications. Now, for the most part, when you write applications for this class, the ones that you're going to be writing for are targeted for smartphones. You don't have to worry so much about the tablets. You don't have to try to create an application, at least for the staff's project, that works on every single Android device that's ever been created, because it is a lot. But we do expect that you are able to support a number of versions on sort of standard, typical smartphone screen sizes. And that sort of limits the space that you have to create these applications for, but it does still show you the sorts of problems that we can have when we're actually working with Android development. So let's say you've gotten to the point where you've installed Eclipse and everything is up and running. So it's going to sort of look like this. You're going to have a variety of projects on the left, maybe not quite as many, but these are the projects that we're going to iterate through over the next few weeks as we start talking more and more and getting deeper and deeper into the Android SDK. Along the top are some buttons that are going to be pretty useful. Some ones that I want to point out immediately are this big green play button. That's the button that you would use to actually compile the code and run it on either an emulated or connected physical device. This little bug right here it does pretty much the same thing, but it enables the debug features so that you can then use step through and step over and all those sorts of and breakpoints and all sorts of neat debug features that are available in Eclipse. Some of the other ones you're probably not going to use all too much, but some of these icons up here, like this one where it looks like there's the little Android guy peeking over a little gray box with the downward arrow. This is for that SDK manager. The AVD manager is the one right next to it. And one of the relatively new features in the Android SDK is a lint, which is basically just a thing that allows you to, when you run lint, it will actually verify that a number of things are actually okay with your project. This happens to be run automatically whenever you export an Android application, but I thought I would just point that out. Now, most of the time, your Eclipse screen will look something like this, or I suppose rather it will look something like this when you actually have some code up and running on it. But notice that you can actually change in Eclipse the context, or what it calls the perspective, that will move around some of the windows and provide to you different windows that are more appropriate for whatever the context is that you're actually working with with that application. So normally when you're coding, you'll probably have the Java perspective open, and it just looks like this. But when you actually want to start debugging, then you might actually switch to one of the other perspectives, like DDMS, for example, which shows us a lot of information. We'll talk about this in just a moment. Perhaps also debug, which is something that moves the source code down to this middle part, as you can see, and will actually show you what the contents of various variables are. It has some additional buttons for stepping into code, stepping over code, starting and stopping the code from various breakpoints and that sort of stuff. So all of these perspectives are useful, but keep in mind then that if it happens to change perspectives on you, don't be too alarmed. Sometimes it will do that, especially if you click on the little debug icon up here in the top bar. It will actually change to the debug perspective. Don't be too alarmed. You can just switch back automatically, or not automatically, but you can switch back easily by clicking on the Java perspective there. All right, so how then can we actually create an Android application? Well, in order for us to do that, it's not that hard. All you have to do is go to File, New, and I apologize, right now it's off screen, the menu, but once I click File, New, I get a whole bunch of different stuff. And the one that you want is, in fact, an Android project. So when you create a new Android project, it guides you through the steps to create a basic level or just the most basic project that you can imagine with Android. But what it does for you is it pre-creates all of the hierarchy and all of the structure that's necessary to actually compile and successfully run an APK file. So we need a project name. So let's say I want to create a Hello World application, for example. I want to create a new project in a workspace. All this stuff is fine. The next window asks what the build target is going to be. Now, there's an important distinction here. We're going to see a build target, which is this, and we're going to see a minimum SDK version in the next window. And there's an important distinction between the two. The build target isn't necessarily the earliest version of Android that your application is going to work, but it is the latest version that you tested your application. So in this case, I happen to have an emulated device which is running 4.0.3, so it's probably reasonable for me to have that version checked, which means that this is the latest version of the Android OS that I've tested my application, and I know that it's going to work without needing to enable any sort of backwards compatibility APIs or anything like that within the OS itself. So if you are not using an emulated device and you're perhaps having a connected device to your computer, then maybe you're not going to use 4.0.3, but whatever version your Android device is running, which in my case is Android 2.3.3. So you just select whichever one is appropriate for your case. In this case, I will say that this is going to be appropriate here. And the onus is on you to make sure that you get this correct, because Android's not going to, or Eclipse isn't going to care which version you actually say. It's just for your benefits to tell the Android OS when it runs your application whether or not it's been tested on that OS and therefore will work without needing to enable any sort of backwards compatibility APIs. Now, notice that there's something up here called the application name. It's named immediately after the project. In this case, it's fine. When we are actually creating projects, or when you're creating projects that you will submit to us, pay attention to the specifications, because we tell you exactly what the project and application name should be, and also what the package name should be as well. So notice that the package name deals with namespaces, and generally it's going to be in the form of a reverse domain. So if you had, I don't know, something like, you might have seen this last time when we were actually dealing with them, but in our case, we're just going to use net.cs76.lectures.helloworld, for example. And that's just basically a reverse domain name that uniquely identifies this one project. And it's important that this uniquely identifies it. If you actually happen to use something that conflicts with another package, this could cause all sorts of problems, especially when you submit your project to us. If that package name happens to conflict with somebody else's, we will actually see some problems as a result. So that's when we tell you the package name, it's usually going to include your HUID, which will make that package unique to you. And so pay particular attention to that requirement in the specification. But in this case, this one happens to be unique for my workspace here. And right now it says create activity. We'll talk about activities in just a moment. And then right here, this is that other field that I mentioned before, the minimum SDK. So this is the minimum version that your application will install and run on an Android OS. Now, for most of the projects that we are going to be dealing with in this class, that's going to be a version 2. I think it was 2.1 or 2.2, and so you will then pick the appropriate version there, like 7, for example, which says that this application can run on OS versions 2.1 and up, but it will not install. Android OS will not let this APK file be installed if you're attempting to do it on an earlier version. And again, this is distinct from that targeted version that we saw on the screen before, because that targeted version means that, yeah, I've tested it up to this version, but I know the minimum version that this application will run on is this one right here. So minimum SDK, Android 2.1 is generally what we're going to be working with. But if you know that your application is going to work, especially for applications outside of the context of this class, if you can make it simple enough to work on older versions as well, then you might as well do that so that you can get a bigger piece of that version pie. Now we're going to skip this create a test project, and when we click finish, it's going to think for just a moment. We see that we have a new project right here called Hello World, and this is the project that we had just created. And notice that it has in fact created quite a lot of stuff for us. There's a source folder. Oh, stupid thing. Source folder. There's a gen folder. Stop it. There's a gen folder, which is generated Java files. We're not going to generally be modifying anything in there all too much. This Android 1.5, that's just some documentation, some links to some documentation that's made available because I specified that as the minimum SDK version. Assets and res we'll actually talk about. Bin is the actual compiled version of all the source code. And then there's some other things that are required, as we can see here. Android manifest.xml and project.properties. Now, what do these files actually provide to us? Well, it provides a minimum amount of information to the Android OS to actually run our application. So XML files you're going to see all over the place. We're going to use XML files to define some layout, for example. You can use XML files to even create animations and a variety of other things like that. And you can use them to create shapes and all sorts of different things. So these are important because it allows us to be able to easily edit and modify these files, but they can also be compiled by, it's compiled in one of the steps when we're actually creating an APK file into something that's specific, into some binary form that the Android OS can actually read in a very easy way. So notice that this XML file, and we'll talk about some of this stuff over time, basically just defines some basic properties about this application that allows us to run it on an Android OS. Now the meat of this project, all of the source code goes into this source folder. Notice that within the source folder we have the package name, so that our namespace, net.cs76.lectures.helloworld, and within that we have a Java file which represents the entirety of our program. This is what it looks like. It's kind of basic. Notice that it looks kind of basic, but that's because, oh my goodness, sorry about that. But that's because Eclipse is actually hiding some of this stuff for us. Notice that next to that import line up here, there is in fact a little plus sign. So if I click that plus sign, we can see that we're importing a variety of Java classes that are going to be useful to us in this application. So this is pretty much the most basic application that we can create. If I want to run it, I can. Notice that right now I have two devices that I can actually run this application on. One of them is the emulated device, which we saw just a moment ago. One of them is a physically connected device, which I'll show you in just a moment. But I want to try to run this on the emulated device. So notice the console down here. There's some stuff that's actually happening. It actually will tell us that it's building it, if there's any errors, and it's installing this application file in the emulated device. Whether or not it's successful, then it's going to start this thing that we're glossing over so far called an activity. And so if I switch over to this emulated device, we can see that my application has in fact started, and it's a little crappy. It says hello world activity, but it does in fact work, and this is the most basic of applications. So you're basically what I've done for you is your setup project. I've shown you how to get your setup project up and running. There's a little bit more work you have to do, but just keep in mind that this is really how we can get started with an Android application. All right, so what then does all of this stuff mean? What does all of this code actually mean? Notice that when we're actually taking a look at this code, we do not actually see a main method, right? There's no main method like we saw in the Java source code that we had last week. And in fact, there's a lot more words going on here. The words are a lot longer. What does some of this stuff actually mean? Well, all of this is still Java, but if we start to break this down and take a look at what each of these things actually are, hopefully it will make a little bit more sense to you. Notice at the very top, for example, so yeah, we've defined the package as we saw a moment ago. We've imported some Java files. All of that is well and good. But really, the interesting bit starts here, where it says public class. So we're creating a class, as you might recall, and there's this word extends again. So recall from last week, what does extends mean? Right, so it's a subclass, so we're inheriting the properties of this thing called an activity. Now you're going to see this sort of thing a lot. You might actually open up some Android code and you might see something that looks like this. One of the first things that I recommend that you do if you are starting out with this is to actually take that name, that activity name, and actually look in the developer documents to see what sort of thing you can find. So all I've done is I've just searched for activity. We can find that there is, in fact, some documentation for activity that gives you a whole bunch of information about what an activity actually is, all of the methods, because the activity is obviously a class, all of the methods and the properties that are associated with it. But an activity actually happens to be important enough that you don't have to go and do this right now to figure out what it means. I'll actually tell you what an activity is. An activity is basically just the thing that the user interacts with. When I opened up that window and we saw that text at the very top, that was the entirety of that activity. And this, in fact, is sort of an important point with regard to Android development as a whole. When we talk about an application, we really have to be distinct between the term application and what Android considers what we might think as an application or a task. So in other words, when we're actually running a program on an Android device, it just so happens to be the case that you can have multiple applications running on the same device. And what I mean by that is that you can be working with an application, and let's say that that application brings up, for example, a Google map, for example, or it happens to bring up an image picker from somewhere else. That image picker, that Google map, can actually be from another application altogether. I know that sounds kind of confusing, a little bit backwards, but that's why it's important for us to distinguish between this concept of an app and a task. So when we're actually working with something on an Android device, what we're actually working with is in fact a task. So let's say that I open up, all right, so here's an puzzle application. So I open up something that looks like this, and this is actually an application because it contains a lot of stuff. I just started opening an application and running a lot of stuff, but there's different windows that exist within this application. And this collection of windows are a series of activities that are basically organized into a task. So I have here one activity. This activity right here, you can see is an image picker. When I click on one of these images, notice that it slides to the side. Then what we're doing is actually then opening up another activity, and that activity sits in front of the previous one in this task. So in this context, this is actually the same program. This is actually the same application that is providing a series of activities that the user is interacting with. But that doesn't always have to be the case. And when we start talking a little bit more deeply about activities, you will see that we can actually initiate activities from other applications and open them on top of our task, so that the experience as a whole looks to be like one fluid application to the user, even though it's made up of multiple programs that are actually running in the background. So let that concept sink in. We'll talk more about it a little bit next week, but just keep in mind that when I talk about a task, the task that I'm referring to is in fact that entire user experience that that person has as they're interfacing with your application, and it might actually be spawning other programs in the background to bring up new activities. But at the most basic, the activities that we are referring to here are just that window that the user happens to be interacting with. So I can actually run this on the hardware device by selecting that. It's going to compile and install, and what we see is that we see our program running with our one activity. And this activity has a UI. You are responsible for creating the UI within this activity, and right now it's very basic, but this is in fact an activity that's taking up the entirety of the screen and running our application. So with that in mind, this is why we don't have a main method. There is this activity class, and there's in fact parent classes to this that are responsible for actually running all of this stuff, actually creating all of the views and creating all of the UI that then make it possible to draw on the screen and run our application and run our program on the screen. So what our classes have to do whenever we're dealing with activities, this is precisely the thing that we are dealing with. We are dealing with this object that is then going to be responsible for drawing our UI and interfacing with the user. It's going to be able to accept inputs from the user. You can actually modify the UI elements to provide output to the user by changing text, for example, or any number of things. And this all happens through this concept of an activity. Now, that is why we then do not have a main method. But in fact, what happens is that there's within this nebulous concept of the source code that was written for Android that we don't get to see right now, elsewhere there's a cycle, there's a certain sequence of events that have to happen in order for this activity to actually open and be run on this device. And this actually refers to something called an activity lifecycle, which actually goes from through a very well-defined sequence of steps to actually get your program up and running. And so among these, and we'll talk more about this, and so I know we have to sort of delay all of this stuff. We have to at least lay some foundation before we can start talking more specifically about some of these items. So one of these things happens to be a method called onCreate. And onCreate is a method that's actually implemented in this activity class. And what we have to do in order to get stuff to show up on our application is to override that method, that onCreate method that was implemented elsewhere. We actually have to override it and use that method to create our UI and to display a UI to the user. So that's why we don't have a main method, and that is why, in fact, you have this public void onCreate method, which accepts this bundle saved instance stage, which we don't really care about right now, but it accepts some data that allow us to be able to run our program from one instance to the next. So whenever we override one of these methods, and we talked about this a little bit when we were extending classes and we wanted to override the constructor class for the superclass, we also had to call then the superclass's constructor. Well, you have to do the very same thing. When you're overriding one of these methods that's implemented by one of these other classes, you have to call super.that method. So in this case, we are overriding this onCreate method, and we are then implementing our own. But the very first thing we have to do is tell Android, okay, that's all well and good. I want you to run my method instead of the other one. But first, you should go run that method first, just to make sure that everything is up and running. If you actually were to comment this out, or you were to forget it, you would get an exception in your application. It actually would crash because it's not actually following the proper sequence of events that need to occur. So then the very next thing that we can see here is it says set content view to something, r.layout.main. And so set content view is a method that's been implemented elsewhere, in fact by the activity, that allows us to provide into it a series of UI elements, or rather more specifically a layout object that is in fact created in XML and allows us to then write or display that file on the screen. So in terms of code, there's not a lot really going on here. A Hello World application for Android is really pretty simple. If we can actually break down what each of these things actually mean, it's not all that complicated. But there are a variety of ways that we can create a Hello World application. There's this way, where we can define the layout using this set content view, and I'm not going to show you the XML quite yet, but in just a moment I will. And we can define that layout in an XML file and then do it that way. But you can also create all of these views programmatically as well. And that is what code 1 is going to show us. And so I hadn't yet had a chance to put up some of these code samples, but they will be online very soon, especially since these initial ones are just Hello World applications. There's not really a lot for you to mess around with quite yet, but in subsequent weeks we'll certainly be posting those before class as well. So here, this is actually the first Hello World app that you might create. So rather than actually using a layout file, one of the things you might do is create those UI elements programmatically and insert that and create this structure, this tree structure of UI elements, and insert that into the activity and tell the activity, okay, this is the root of our UI sets and we want to display this on that activity. And that is precisely what is happening in this one. So really the only difference between this code is I still have a class that's extending activity. I still am importing a variety of things. I still have a package that's defined. But what we are doing after we actually, after we call our superclasses onCreate method, is we are creating a couple of objects. In this case, a text view. So there's an object that has been defined somewhere called a text view. And we're instantiating a new copy of that. Then we're running a method on it. We're saying that this text view, we want to set the text to something. And then we want to set the content view, or we want to set the view of this activity to be that object that we have just created programmatically. And what does this look like then? Well, this is probably not going to be that big of a surprise. No, I don't want to save those changes. I will run this on the hardware device. What we actually see there is this. It just says, oh hi, and that's it. Now, I want to go off into just a little bit of a tangent. This is actually, if you happen to have an Android device, a physical Android device, I actually find that I prefer to use the physical device to code on then the emulator. However, that doesn't diminish or trivialize the usefulness of the emulator. Every time I want to be able to test on different OS versions, for example, or I want to test on a variety of devices, I have to turn to the emulator as well. It just so happens that with my laptop, it has low enough memory that running the emulator at the same time kind of makes it into a little bit of a struggle. It's something that you can do, but I do, just for a variety of reasons, prefer to have this sort of thing going. So if you happen to have an Android device that you can use for development, it's actually a pretty nice thing to do, and it's not that hard to set up. All you have to do is go into the settings, go into applications. First, you need to allow unknown sources. Right here, you can see there's a little check marks there, which means that you can install applications from arbitrary places. And then you go into the development menu, and you enable USB debugging. I also find the stay awake feature to be pretty useful because it's going to be plugged in anyway and it's going to be charging, so it doesn't really matter. It's not going to be wasting the battery. That also tends to be pretty useful. But once you do that, then you can connect your Android device using USB cord, as you can see here, from the device to the computer, and the computer will actually recognize that device and will provide that window. As you in Eclipse want to start one of those applications, it will then run it on that device. And so that's a pretty handy thing. Now, if you have a Mac, it just works. You just plug it in and it works automatically. If you have a Windows or Linux machine, you actually have to install some USB drivers. I recommend going to the developer site if you are using one of those platforms to find what the specific instructions are to get that final step working on your own computer, so you can then use that hardware development if you so chose in that context as well. Now, there's another thing that I want to mention as well, and that is that we can actually see what the computer thinks we actually have connected to it in terms of devices, in terms of Android devices, using that ADB platform tool that I mentioned before. So once you install the SDK, you're going to have a whole bunch of tools and platform tools installed. And if you open up a terminal window and CD and you change directory to where that location happens to be, you can then use them. So in this case, I happen to have the SDK installed in Applications, Eclipse, Android SDK, so on and so forth. And then within that, there's this platform tools. So ADB is found in the platform tools of whatever folder you installed the SDK. Once you install the SDK, you can CD into that directory, find the platforms tool directory, and in there you will find that ADB application that you can then use for a variety of things like this, which is actually pretty useful to find out what devices the computer actually recognizes as being attached. So in this case, we can see that we have two devices. One of them is an emulator, and another one is an actual hardware device. And we can actually install a variety of applications through this ADB. So if you want to do, Well, I suppose the best way to do this is just to show you what the options are in ADB. We have a variety of things that we can do. We can list the devices, of course. We can actually push or pull data to from those devices. We can actually open up a shell, which is pretty cool because then you can, it's actually, since it's running a modified version of Linux, you can actually get into that, it's like that mini computer, and be able to initiate arbitrary commands there. It will be somewhat limited because you do not have root access on that device, but it still is something that can be useful. Logcat we're going to talk about in just a moment. You can also install or uninstall packages. Now this is very useful. If somebody happens to provide to you an APK file, or you download an APK file onto your computer and you're skirting the whole issue of using the marketplace or what have you, you can install that on your device, on your physical device, by still going through those same steps, but using ADB install and providing that APK file, and it will then install that arbitrary APK file on your device. Of course, be careful what sort of things you're installing when you find on the internet, so on and so forth. But all of those sorts of warnings notwithstanding, this is a pretty useful tool for you to be able to share your application, not only outside of the context of the marketplace, but you could share it with your friends, with your family, if they also happen to be running Android devices. There's a variety of other things here, but really those are going to be the vast majority of things that we're going to be using. Now, ADB itself operates in a server-client fashion. Both the server and the client are in fact running on your computer, but it's necessary for that server to be running. Every so often, you might get some weird error messages from ADB saying something like device is not found, even though you know the device is connected, or you know that the emulator is actually running, or it says something like server not running or something like that. If that happens to you, and this is just sort of a precautionary thing, or rather just a forewarning, I suppose, one of the things that you can do is first kill the server using ADB kill server. And I'm not going to do it now because it's working and I don't want to actually kill it. And then immediately following that, you can start the server, and usually that will fix a lot of the problems that you might actually have with ADB. So kill the server, then restart the server, and that will fix some things. But it's not something you're going to have to do a lot. Just so happens, just today I got an error and I had to restart the server, and that fixed it. So just keep that in mind. It's something that could be useful for you when you're actually working with this stuff. All right, let's take a quick 5-minute break, and when we come back, we'll continue talking about Android development. Welcome back, everybody. So just before the break, I started showing you some of the things that we can actually use ADB for. And one of the things that I think is most useful, even though you can still reference this from within Eclipse, I find it most useful to have ADB showing us in a separate window from Eclipse a copy of the log that's actually running on that device that we are running our application, whether it be the emulated or physical device. And you can do that through this thing called Logcat. So one of the features that ADB actually provides is this thing called Logcat. Now if I run it, notice that it actually gives me this error that I'm running more than one device in emulator. And so if you actually take a look at the flags that you can provide to ADB, one of them is whether or not you want to run ADB against a specific device, rather a hardware device, to a specific emulator. You can also provide to it the specific serial number. So if you recall, that ADB devices list actually shows us the serial number of that particular device. In this case, I just happen to have one physical device connected, so I can tell ADB that I want to run on that one device. I can do ADB-D, which refers to the one hardware device that's connected to my machine, space logcat, and when I hit enter, we see all this stuff. This is the log that's actually stored on this actual physical device that I can actually see. And so as I actually use this application, or rather, as I actually use this this phone, we can see that stuff is actually coming up and appearing as I actually do a variety of things on it. And so a lot of this stuff we don't care about, right? We don't really care when we're working on our application what the input manager service is actually doing. Notice here that it gives a very specific sequence of output here, and that is, first of all, the very first character is the level of this log. So in this case, W means warn, E is an error, D is a debug, V is verbose, variety of other things as well, I is info, and then there's also a slash. Now I'll make this text a little bit bigger. So and there's also a slash that we can see immediately after that, and then there's a name. Now this name is actually something that's been arbitrarily picked, or possibly arbitrarily picked, can be arbitrarily picked by the developer of an application, and they're sending this message right here, aggregate from so on and so forth, log, so on and so forth data, from this tag called event log service with this log level, or I. And you can actually take advantage of this in your applications. And in fact, this is something that I suggest you get into the habit of doing right away because it's going to be very helpful. This is basically your Java console. This is basically the way that you're going to be able to output state from your application to yourself as the developer without having to actually use the debuggers, without having to step through and actually look at the varying state of all of your variables in various classes and all this stuff, that you can actually watch your application work if you have a good amount of log methods that you employ within your application. So how then am I able to do this? Well, I show an example of this in the very first code example. So in code 1, or rather in activity 01, there's that Java file code 1, and within it, the very last line of code is this. It says log.i, then I provide to it something called activity 01, and then a message. And just like with other aspects of Java, if you have an integer, for example, you can concatenate that integer in. So maybe you want to output some state, something that you're computing. You can do all of that in this string. But notice this, what's happening here. There is an object called log, and within it there is a method called I. In this case, I refers to the level that I want to log. So there's a corresponding level for all of those different levels that I mentioned before. E for error, D for debug, V for verbose, W for warn. Whatever is appropriate, you select here in this method. So in this case, I just want to provide information. It's not an error. It's not a warning. It's nothing like that. I just want to provide information to myself from something that I am calling activity 01, and with this message completed on create. So when I run this application, what we should see is that message actually appearing in the log cat. So I'm going to run this application on my hardware device. You're just going to have to trust for a moment that it is in fact running. And let's see, did I do this right? Well, let's see, this is part of the problem now that we actually have with using logcat. That is that there's so much other stuff going on that it makes it very difficult for us to find the one specific message that we want to be able to use. So there is actually a solution to this. We can actually specify to logcat which tags we want, or which warning levels, or rather which levels of the error we actually want to see output out of a filter through logcat. And so rather than use logcat directly like this, what I find to be a little bit better is to in fact silence other tags. So there's an asterisk :s, which means that I want to, there's two designators here. The first is the tags that I want this filter to apply to. The second is the level that I want it to apply to. S is a special level, which means that I want to silence a particular tag. An asterisk obviously means all in this case, so I'm going to silence everything. But what I do want to see is my tag, activity 01, and I do want to see all of the levels from that. So when I hit enter, we can now see all of the contents within logcat that have been output by my particular tag. In this case, you can see it's activity 01, which is the tag that I specified in that method. I, which is that I method, that information level that I provided before, and also the message that I actually output. So I'm not just limited to using just one of these methods. I can have as many of these methods as I want, make it as verbose or not as I actually want. And this is something you should get into the habit of using right now, because as soon as you start working on the staff's project, you're going to need this. You're going to be computing a variety of things. You actually going to see the results of your computation, because most likely it's going to be incorrect at first. You want to see that. Using logcat is a good way of being able to do that. So if I actually run this application again, I'll go back up here and actually run it again. We should actually see that same message occurring a second time. So I switch back over here, and after a minute, is it going to do it? No, it's because it hasn't actually run it again. All right, there's live demo fail, but basically there's this complicated issue that we'll talk about later about how when you quit an application, it doesn't actually quit, so it's actually still running. So there's a whole bunch of things. Yes?
Do you have this output dynamically at runtime, or is it you run your app from beginning to end and then you dump it?
This is in fact dynamic, and so that's what I was trying to show you, is that by running it again, this will actually show you the latest lines in logcat that apply to this filter. And so I could actually, I suppose one thing that I could do is actually have this output a second line of code. So now I want to do an error, for example, with the same tag. It's important that you actually use the same tag. So what might be a good idea here is to actually use a constant that you can define elsewhere and be able to reference that same constant everywhere within your log methods. This is an error, for example, and then I can call it a day and then actually run it on my hardware device. No, I don't want to do that. Run it as code 1, so it's going to run on my hardware device. It's building and installing, and right now it's being run. And now if I take a look over here, we can see what the result is. So it is actually showing us live what's happening. If I switched over more quickly, you would have seen that those lines are actually added dynamically. So that's not something that you have to worry about rerunning logcat or what have you. But there's an additional thing as well. When Eclipse, or more specifically, when ADB, that's what's running in the background in Eclipse here, detects that you have some logcat function that actually spits out an error, notice that what it did was it changed the perspective slightly to show me the logcat issue that I had here. And this is actually a nice new feature that they've implemented recently. Before, you really had to dig for logcat to be able to see it, but we can actually see my error at the very bottom here. It's shown in red because I used the error level error in this case. We can actually see what the result of that actually was. But the reason that I like to have this running in the background is because I might have a lot of logcat stuff being displayed, and as you can see, Eclipse is already cramped enough. It's kind of hard to see all of my warnings in just a few lines. Instead, having a separate window like this makes it a little bit nicer to preview my errors and my warnings that I'm outputting from my application through ADB. So this is something that you should get used to doing. If you want to find out more information, there is, of course, a lot on the Android developer site. But there is one more thing that I want to mention with regard to logcat as well, and that has to deal with the using it through the GUI. So you can, of course, still use logcat and still view logcat's logs through the GUI as well. You can also, one of the nice things about this is that you can also use grep to be able to search through not only just the tags and not specify the log levels as well, but you can also use some fancy search heuristics here, including regular expressions, to search the raw text itself so that you can look for specific messages that have been output here. So that's another nice way of being able to use logcat. But realize this is really important that this exists and that you should use this. You shouldn't use system.out.print because that's not going to help you. It's not going to go anywhere. What you should use whenever you want to output raw data to yourself is using this logcat, this log object here. I can't stress that enough. It's going to be extremely helpful for you as you work on your Android application. Any questions on this? Yes?
This ADB is a server, right? It's running in the background.
ADB is a client and a server, and it is the server is in fact running in the background. When does it start? Let's see. I don't know if it starts at runtime. It seems to be running whenever I need it to run. It might start with Eclipse. I don't actually know when it actually starts, but if you find that it's not running, you can actually force it to start by using the start-server command, and it will then start running for you automatically, or not automatically, but based on that request. Any other questions before we move on? Yes?
What about stepping through code?
What about stepping through code? So that is actually a debug function that's provided by Eclipse. And so realize that we have two different contexts here, DDMS, which allows us to see a lot of information about the device itself, but there's also a debug perspective as well, which allows us to do that very thing. In Eclipse, you can actually set breakpoints just by double-clicking on the line of code or in the column directly to the left of the line of code. Notice that in this case, this thing is really driving me crazy. Notice that right here what I've done is I double-click to the left of this line that says tv.setText, and it is in fact showing me a little blue dot. That blue dot means a breakpoint, which means that if I run this code in the debug form, so using this little bug icon here, and I don't want to save that one. Let's see, and then I want to run it on the emulator in this case, just so that I can show you what happens. So on the emulator, it's going to load after a couple of moments. It says it's waiting for the debugger. That's okay. All of this stuff has to connect together. ADB has to provide this connection together. And now we can see it has switched to this debug perspective, and the code is actually paused on this line of that's highlighted right here. And if we go back to this activity, we can see that no text has actually been shown in the emulator. Before it said "oh hi" or something like that. That text is not actually shown because right now it's just suspended. It's waiting for you to actually provide some input. And notice that up here along the top, we actually have those specific functions. There's a green button that allows us to resume operation, and it will continue going until the next breakpoint or the next error. There's also step in, step through, step over. All of those functions are available here. Step into is useful if you want to, if you're not familiar with this concept, you use a breakpoint, basically just pause execution of your code. It will pause at the breakpoint that you've actually specified. You might isolate, the reason that you might use a breakpoint is because you might suspect, for example, a method is failing, is crashing. You actually want to analyze the state of your application as you go from line to line before it actually crashes. Then you can not only identify the specific line that it crashed, but also the state of that application in the lines immediately previous to that actual crash or that exception that occurred. So you can use these. For example, step into is if you actually want to then go into this method called setText and then pause execution on the first line of code in that method and continue on. Sometimes in that case, I know that setText was written by the developers that wrote the Android OS, or rather the Android API. And so I probably don't want to step into that because that's not code that I'm responsible for. So in this case, I might want to step over, which means that it's going to go to the next line of code in my method. So now you see that it's paused execution at setContentView. So now what I've done is I've actually run this previous line of code. So now what I should see, if I were to take a look at, and well, I suppose what I should have done before was actually show you the state of this object. Notice that up here in the upper right-hand corner, I actually have that TV object, that text view object that I defined before. So now what I should see as the text for that object, and you have to sort of scroll down because this is a big, complicated object that's been implemented for us by the developers. You should actually eventually be able to find the text that's representing that. In this case, we can see here it's been set as "oh hi." Before, at the previous breakpoint, we would not have seen any text in here. It would not have been set before. So that state has changed from a moment ago. We can also see all of the various variables that I've created. In this case, it's a very basic program, so you don't see a lot of field variables. But you could track those changes as in the state of your variables, and we could continue stepping over to observe what happens. So now I've actually set the content view, so what I should see, oh, it hasn't actually completed that, but if I were to resume this application, then you would see that it then completes running that application until the next breakpoint, until the next error or what have you. You can continue debugging that way. So this is actually a very useful tool as well. Set breakpoints if you think that your code is failing at some particular point. Go a couple of lines up, set a breakpoint there, and step over each of those lines. Find out where that code is actually failing. You can then isolate. You can hone in on the specific thing that's actually causing that. In combination of this, the variables, which shows you the state, and also isolating which line specifically is causing that crash or that error. So if you don't want to run that breakpoint, you have a couple of options. You could either remove the breakpoint altogether by double-clicking it on that column at the far left, or you could just run it normally without the debug, and it would then just ignore those breakpoints and continue on. Other questions? Yeah.
I got another logging question.
Yep.
How come we can't use WebSphere console for logging?
Why can't we use WebSphere console for?
Right there.
So that's because the output is not sent to standard out. So if there's any standard out that's being captured, it's not actually going to be shown. All of that stuff is redirected within the context because Android is in fact a modified Linux platform, and so logcant is their way around standard out and standard error not actually being output by the device itself. All right, so this might be a good point to show you this other perspective as well, DDMS. This is actually something that's pretty useful, not so much for Hello World applications, obviously, because they're very simple, but as your applications grow and become a little bit more complicated, you might be using a lot of memory, and you might actually want to find out what exactly is using that memory within your application. You can use the DDMS for this function. So what I can do, for example, is actually set So notice that I have here on the list of devices in the upper left-hand corner, both of those devices that I'm currently running, not only the hardware device, but also the emulated device as well. And if I expand one of these devices, I can see all of the tasks, all of the applications that are running within that device. And I can select mine. In this case, I just happen to know, just because I start my package name with net.cs76, I just happen to know that this one right here is the one that I'm interested in. And I can actually look at the heap information that's being used by that application when I'm, let's say, I suppose I should do this one here. That's actually being used by that application. There's a variety of things that you can do from here as well, including taking a screen capture of your emulated or physical device. Notice there's a little camera icon that's right here that allows you to do that. Some other neat things, you can actually take a look at the files that exist on that file system. You might not have the ability to write to all of those files, but you would be able to at least look through the hierarchy of files and be able to download or manipulate some subset of those files. And also there's an interesting one over here, emulator control, where you can actually replicate some of those features from that telnet feature that I mentioned a little while ago. But I think one of the most useful features of this emulator control is if you scroll down a bit, there's the location controls, and what you can provide here is a GPX or a KML file with a sequence of GPS locations, with the sequence of latitude and longitude coordinates that this will then step through as though it were a user that's following some path that you defined in one of these two types of files. And then that emulator will be able to replicate those latitude and longitude coordinates, and you can use that as a way to test your geo-capable application. So that's sort of a neat thing to do if your application is using geolocation. Yes?
Does that also work on a phone? Or does it only work on the user device? Because I tried it on the phone, it's grayed out.
You tried it on a phone and it grayed out. So yeah, it so happens that on a phone, I think on the phone, you have to explicitly state if you want to be able to override its location. Let me see if that happens to be true. Development. So here I suspect that the way to get that to work would be under the development menu. Right now it says do not allow mock locations, but if I check that, then I would probably be able to override that option in not Logcat but DDMS. Be able to use that. In this case, I don't want, but in this case, I might actually want to use my phone as an actual, I might want to use the legitimate GPS locations, latitude and longitude that it's calculating and actually test my application that way, but it's something that you could do, looks like on this, on the hardware device as well. All right, so keep all of this stuff in mind as you work on your application. It's going to be quite useful and handy. Now, if we come back to this raw code here, let's take a look at what is actually happening, what the difference is between this application that we saw that we've been working with just sort of lightly, and also the one that we started with at the beginning of our discussion of this Hello World application. So what we're doing is creating two Hello World applications, but we are instantiating the UI. We're creating the UI in two very different ways. Now, if I wanted to create it programmatically, this is precisely the way that I would do it. So I would first set my package, do import. All of this stuff has been pre-written for us, except that when I want to actually create and instantiate a view, and a view in the context of Android is an object, and there's multiple different types of views. A view is an object that is actually going to be displayed and rendered on an activity for interaction with the user. Now, a text view is pretty simple. It's just that. It's just going to show some text. But there's other views as well, like buttons, for example, pickers, sliders, all sorts of funny things. Images or views as well. Movies, all sorts of things can actually be views. And there's actually this hierarchy of views that has to be created when we are creating our activity. So a hierarchy of view might actually look something like this, where we have a view group, which might allow a collection of subviews. For example, let's say we wanted a text view and a button, and we wanted to display those side by side. We need some root object to contain both of those views. So there's this hierarchy of views that we have to create, where there's a root object, and that root object in collection with all of the leaves and all of the sub-objects below it are actually responsible for creating the UI that we then see on the activity. There's two ways that we can create these layouts. There's two ways that we can create these views that are then displayed. One of them is programmatically, as we saw just a moment ago, where I can actually instantiate a new view, modify the properties of that view, and then tell the activity that its view, that the root view should be that one view. Now obviously I could create other views as well. If I used some view group, for example, to collect not only this text view but also a button, then I could probably provide that root view to set content view and be able to display both of those objects. So we could create our entire UI programmatically. But there's another way that we would be able to do this as well, and that would be to use actually XML files. And XML files is a really neat way of being able to predefine some of your views, or to predefine your UI and create that outside of the context of having to sort of guess and check what it's going to look like. So there's obviously pluses and minuses of both methods. You have to decide within the context of your application whether you need to create that view programmatically, or if you want to follow sort of a more MVC model, model view controller, where you are able to separate your display of the data by creating an XML file, and it doesn't actually have any data, but it's just purely the layout, from the actual content itself. And so for that reason, using XML files tends to be very useful for the context of our application. So here, notice that when I create, there's one thing I want to point out. When I open one of these XML files, there's a couple of tabs along the top, and those are the open files that I have from the Hello World application from a few moments ago. Uh-oh, see, this is what happens with too low RAM. Then all the way to code2, code1.java. But when we open up an XML file, notice that there's even sub-tabs along the bottom of that window where we could see, for example, the graphical layout, but also the raw XML that makes up that graphical layout as well. Luckily, and you guys are very fortunate to be getting into this now, when we first started dealing with this stuff, it was pretty much entirely XML. That means that there was a graphical layout, but honestly, it was terrible. It was not even worth looking at because it was frequently full of errors. It was never showing it properly. It had no real utility in terms of a WYSIWYG editor in order to create a layout or a view. Luckily, now Google has made great strides in making a WYSIWYG editor for their layouts, and you can actually preview what it's going to look like. And this is a pretty decent preview of what this admittedly very simple layout will look like on a device with these properties, which happens to be an Android 2.3.3 device with a screen that looks like this, which is, as you can see, is a portrait screen with a size 3.7 inches, with a normal, in a normal mode, and all of these sorts of things. You can actually preview your layout in a variety of different devices in this manner. But if we just take a look at the XML file, we can see that we are defining a couple of different views within this XML file. One of them is a linear layout, which we might be able to guess is a view group that allows us to put a couple of views as children below it. And then, of course, there's still that text view that we saw before. So this isn't a direct translation from that programmatic creation that we saw just a moment ago. If we just did a direct one, we would not have this linear layout, but we would just have that text view. But already does it make it a little bit easier for us to add some additional views because we don't have to actually create all of this stuff. So what actually happens in the background is this XML file is compiled into some binary format that is very quick and easy for the Android OS to read. And when your application is run, at runtime, the Android OS reads this XML file, and these views are actually representative of Java objects. It will actually instantiate for you Java objects that relate to these names. So there's a Java object, or rather an object that's created by the Android OS that is then a Java object called linear layout. And there's another one called text view. And those are actually instantiated. Their relationship is defined based on this XML file, as well as their properties. That is loaded into memory, and then it is shown on your screen. And that's sort of a clue about how we'll be able to actually communicate from our program to some of the views that we deal with in our activity or in our layout that we define in an XML file, but we'll see more about that next week. So anyway, the code then for this particular type of layout instantiation is much easier because, jeez Louise, because when we have this onCreate method, all we need to do is set content view and provide to it this XML file. So right now, I haven't really explained what r.layout.main is, but you might realize that main is in fact the name of that XML file, It is in fact called main.xml. And notice that that main XML file happens to exist within this layout directory in the hierarchy of my application. So this r.something is actually just a reference to the files that we have within these resource directory. We'll talk more about that when we talk about resources in, is it next week or in 2 weeks hence? So anyway, it makes it much easier for us to instantiate a view that is essentially the same, or at least it looks the same to the end user, even though we have used two different methods of defining that actual view. Any questions on this? We'll actually get to see different types of views, different types of layouts, and in more detail next week. But one of the things that I want to point out now is to come back to this idea of an activity. We've sort of been going through what each of this stuff means, and I mentioned that there's this onCreate method, but I really didn't tell you very much about what that actually means. Well, keep in mind that an activity is that thing that the user interacts with in your program. That is what it is. It is this object that the user interacts with. It's responsible for not only displaying all of this content, but also retrieving user input as well. And so there is a life cycle that this activity actually goes through as it's being created, as it's being destroyed for a variety of different contexts. And so the activity method actually has a variety, or rather the activity class has a variety of methods that you can override to provide additional functionality to your application. OnCreate is sort of the most basic. By default, you're going to have to use OnCreate to create this layout, because the activity by itself is not going to have a layout. It's not going to have any content to show the user. You actually have to override the onCreate method, which, as you can perhaps imagine, is the thing that happens at the onset of the creation of this activity. When I actually want to tell the activity what its layout should be, I therefore want to create, or I thereby want to create the layout, instantiate the layout, and give that to the activity so that I can then display that to the user. So that's why we use this onCreate method. It's because it's the very beginning of when this activity is being created. I can then set my layout and display it by passing it to the activity. But there's these other aspects of the life cycle that are important as well. It brings us back to this diagram, which I showed earlier today, but we really didn't talk about it, and we'll go into more detail now. And that is what exactly happens to an activity as a user interfaces with an application. So when an activity starts, that probably means, at least in the context of our very simple Hello World application, that the user has started that app, that Hello World app, or rather more specifically, more correct perhaps, is the Hello World task. And so this task then is going to start this activity, and it's going to go through this life cycle. It's actually, before any of this is shown to the user, it goes through this sequence of methods. It first goes through onCreate, then it goes through onStart, and then onResume. And then once all of those methods have been fired, then it actually shows that to the user, and the user can then interact with that activity and to perform some action in your application. Now, let's say for a second that the user happens to bring up another activity. You might recall that demo that I showed just a little while ago that had the selection of images, then you would select one, and then it would swipe across and it would show you another activity. Those were two activities. There was that first activity, which was the selection of images. Then there was the second activity, which actually was that puzzle or that image by itself. So that first activity was actually essentially closed by the Android OS. And closed is too generic of a word because it does in fact go through this life cycle where it used to be running, where it had gone through this life cycle before of onCreate. It had been created, it had been started, resumed, and then the user, me, was able to interact with it. And then as soon as I did something on that activity to actually spawn another activity in my task, then that initial activity had to go through this same life cycle, or had to go through the remaining portions of this life cycle dependent on where it was going to end up. So it was then paused because it was no longer in the foreground. That activity was paused. So there's that onPause method that was called. And then once it becomes no longer visible at all to the user, in fact, it was completely obscured by the new activity that was up there, it was then stopped. So there's this very important distinction about what can happen to activities as we're working with a task. Let's say that another activity pops up in front of the one that we're working with right now. And that could be just a very simple Hello World app, for example. And we just have an activity that's like a dialog box that obscures most, but not all, of that activity. We would then say that that activity below it was still in use because it's still visible to the user, but it was in fact paused. So that while the user was not interfacing with that activity in the background, it was still visible. And so there's this logical distinction that we can make between activities that are visible but are not being used because they're being slightly obscured by another activity in front of them, to activities that are not being used and not being seen entirely. And that's the distinction that's being made in this life cycle, is that there are different states that these activities can actually be run in depending on how the user is interfacing with your task. So if it happens that there's another activity that completely obscures the one that you're working with, then that initial activity is going to be stopped. But it goes through this life cycle in order to get there. It was running before, then it's going to be paused, then it's going to be stopped. Because stopping an activity means that it's still there, it's still in the background. It's not accurate to say that it's running in the background, but it's still in memory. But the user is not interfacing with it, and the user can't see that activity at all. And this is logically distinct from pausing an activity, which means that that user is not interfacing with it, but can still see a little bit of it because some forward activity is actually obscuring only a portion of it. Now, there's an important thing to mention about this activity lifecycle, and that is that once your activity is paused, it can be killed. So what this means is that if the user is writing something, let's say that you are writing an application for Twitter, for example, and you want the user to be able to send tweets from your application, and then something pops up in front of your application. Maybe you have an image picker, for example, and you want the user to be able to have the capability of attaching an image URL or something like that into their tweet. So there's a new activity that pops up in front of this initial one. Let's say that there's an extremely low memory condition on this device. It could decide, in very rare circumstances, but it could still decide to destroy that paused activity. So what this means is, and the whole point, the whole reason that we have all of these methods available to us to be able to override, is that once an activity is paused, this is the perfect opportunity for you to save the state of that activity so that when it's resumed, you know that you can then recreate the state that the user was interfacing with that activity. So on pause is your gateway. That's where you want to be able to save the state of your activity. And as we start getting a little bit more complex and we start actually moving away from single activity, hello world applications, and we get through some of these layouts, we'll actually show you how you can create multiple activities in your application and why saving the state is important in on pause versus doing it in some subsequent one like on stop or on destroy. There is the possibility in older versions of Android that once it's been paused, it can actually be killed.
Question?
Yes?
Is an activity only within an application?
Is an activity only within an application?
Your application. So if we included another activity for another application, would that put your activity to pause?
Yes. So activity. Yes. So there can be. So I mentioned before this distinction between tasks and applications, where one task could actually be made up of multiple applications or multiple activities from different applications. It doesn't matter what activity from which application obscures yours. If there's anything that pops up in front of yours, another activity that pops up from any application, it goes through this life cycle. It is paused and stopped as appropriate depending on what that activity is actually doing to your app, whether it's completely obscuring it, which would be stopping it, or only partially obscuring it, which would be pausing it.
Is it always visual, or could it be audio if you had like you playing?
Audio is a different beast entirely. So when we're dealing with activities, we're talking just about this UI element or this UI box basically that's being shown on screen that the user is actually able to interface with. This has nothing to do with background tasks or things that you might want to run in the background. Like if you wanted to, for example, have an image uploader that would be able to function in the background, implementing it in an activity would be a bad idea because as soon as that activity has been obscured by another one, then that activity is going to be paused and it's no longer going to be run. So your upload will stall. So activity is just one of the things that we can implement in an Android application. There's other things as well that will allude to, but we're not really going to get a chance to really talk a lot about. But one of them is services, and a service is something that actually does run in the background. You would also have to implement an activity to implement so that the user could then interface with that service. The service would run in the background. It could play music or could upload images or what have you. And that is going to have a different life cycle and is not going to be killed by some other activity being obscuring your application or what have you. There's a variety of these other types of things that are useful dependent on what it is that you're actually trying to implement. In this case, activity is literally just the thing that the user is going to be interfacing with on the phone or on the device. Any questions? All right. Oh, yes.
And you cannot get to the onStop event without going through onPause. You can assume that.
Yes, exactly right. So this happens in order. OnStop will not be called without calling onPause or before calling onPause. So the direction of these arrows is precisely the life cycle, and that's why it's called a life cycle. It's precisely the order in which these methods are going to be called. So at the very onset, onCreate is going to be called, then onStop, then onResume, and then the activity is going to be running, then it might be paused. If it was paused, notice that the arrow, if that's paused again, means that it's being partially obscured. If that activity happens to come back to the foreground, it doesn't go through the entire life cycle starting from the beginning, but based on this arrow, we can see that it does in fact just go back to onResume. And so it depends on which point in this life cycle that we get to that ultimately dictates where we're going to resume from our life cycle previously.
So onStop is not reliable basically for you to save state?
OnStop is not reliable for you to save state necessarily. That's correct. And that's because onPause does not necessarily guarantee that your activity won't be killed. Now, in newer versions of Android, there is an exception to that, but it's better to assume that once you've paused your application, it can be killed at any point after that. It's going to be rare, but it could be killed at any point after that. Most of the time, it will actually get to the point where it goes to onStop first, and then it will be killed, or even onDestroy. But really, there's no guarantee based on the way that memory management in Android works. All right, so don't worry. Again, this life cycle, I realize, is sort of an interesting concept to grasp at first. We're going to come back to this as we start talking more about activities, going a little bit more in depth, and when we actually start creating multiple activities in our application and instantiating them and actually having a multiple activity task that we can then create on our own. We will then see the importance of each of these tasks. But really, the main takeaway for our Hello World application is that because we want to create our UI at the onset of the activity, that is why we put those things in the onCreate method in our application. Now, if we were doing some more advanced things like restoring states or that sort of thing, then perhaps we would create the UI in onCreate, but then restore the state in onResume, or some fancy combination of these methods thereof that we'll talk more in detail about when the time comes. All right, so again, there's two different ways that we can really define these views. We can define it programmatically in the Java code in our activity, or we can define it using XML. And each one has its merits, and it is something that you have to make a decision for yourself when creating your application. And again, these views, these collection of views, we have to have this hierarchy of them where the root view is actually the one that's provided to this activity. And that is how it knows to iterate through or to traverse into each of the nodes and be able to write, or rather draw, each of those views on the screen in the activity in the onCreate method. Now, there's a whole bunch of views and layouts that we're going to see, especially next week. But some of the more common ones are things like this: frame layout, gallery, grid view. So not all of them have the word view in them, but a lot of these are in fact layouts that are then view groups. So we can have views within them. So gallery, for example, might be a view group that includes a bunch of image views, just as an example, and displays that in sort of a neat way, in a way that might be akin to an image gallery. A scroll view is what it sounds like. It allows you to scroll through a variety of objects. You can have let's see, a spinner, which is basically just allows you to spin through a variety of views. I mean, all of this stuff, we're not going to get a chance to go through all of these views, but realize that there are a variety of pre-made views for you that you can actually use within your application and create some very nice layouts as a result of them. However, there's nothing really particularly fancy or special about these other than the fact that they've been pre-written for us. A view is actually an object, or rather is a class that you can extend and create your own views within your application. That's a little bit more advanced, but realize that just like any other object in Java, it's something that you can actually extend and create your own views if it just so happens to be the case that you want to be able to do that as well. Now, there is one more thing that I want to point out, and I know we've been sort of jumping all over the place, but that's because there's a lot of stuff that we have to go over at the onset. Next week, it will start to solidify as we start to become a little bit more focused as we iterate through some of these views in the activity folders, and then start talking about how we can actually instantiate multiple activities within the context of one application. But this right here, this Android manifest file, is actually something that's required in every Android application, and is actually a way that we can define a number of pieces of data within our application. So notice a couple of things that we have defined here. We have, for example, the package. So this is the namespace of our application, which, of course, you've seen a variety of times now. We have a version code. Now, if you are actually creating an application that you're going to be placing on the market or actually selling or giving publicly, this is going to become very important to you. Version code is an integer that you increment by 1 every single time you create a build and release it to the public. So I don't care if you release your project and you want to call it version 2.0a or whatever, you increment this value by 1. It's an integer value, and this is necessary for the Android market and also the Android device to know in a very real way whether or not the application that the person is trying to install is actually newer than the one is actually installed at the moment. So if you actually wanted to get fancy with version names, you can use this string right here, the Android version name attribute, as you can see here, and then you can put all sorts of funky stuff like 1.0-test hello world or something like that, and it doesn't matter, it's not going to impact the remainder of that. Now you might recognize this element right here, not that element. This element right here uses SDK Android minimum SDK version 3. So remember that we specified that when we first started creating the Android project, but it's none of that stuff that we wrote when we first created that Android project is set in stone. You can, in fact, change it at a later point. Some of that stuff is more difficult to change than others. For example, the package name is a little bit more difficult to change than the minimum SDK version, but if you decide at a later point in time that, oh, I really need this API that's available not in version 3 of the API, but maybe version 5, then you can just update it here as well. And so you would then also find in some other applications or in some other XML manifests, you'd also perhaps find the target, the SDK target in this one as well. So within this XML file, so we actually find a couple of things. One of them is this application element, which lists a couple of things. Notice that it has not only an icon, but also a label, and this is what is actually displayed in the launcher. So when I'm looking at my Android device, and I am looking at all of the applications that I have here, notice that right here, we have a couple of CS76 lecture icons. We actually defined the name and the icon in those two attributes of that application element in our XML file. But we also define here the activity. And this is something that's very important to point out right now, is that anytime you create a new activity, you also have to tell Android that you have this new activity in the Android manifest file. Otherwise, it's not going to recognize that it exists. Now, notice a couple of things about this. It also has a name and a label, but right now, one of the more important things to notice is this intent filter. And we have here the main and the launcher, which tells the Android OS that even though there's no notion of this main method, this tells the Android OS which activity in your application is considered the main one. When I first open up this application, what activity should be the first one in this stack, in this task? And we can tell which one it is because we have defined through this filter that this activity is the main one, and it is the one that should be launched when we actually open up this application here. So all of this stuff is defined, and that's how, it's just to reduce some of the confusion when we start talking about multiple activities, this is how we can actually define which activity is the primary one using this filter. When we create a secondary activity, we don't have to worry about actually specifying that secondary one is going to be the main one or is going to be launched when that application is actually launched, because we are able to explicitly define which one is in fact that main one. Any questions on any of this stuff? All right, excellent. And with that, I think we will wrap up for today. Next time, we will continue talking about activities. We're going to go quickly through a variety of layouts and views and how we can actually create some interesting UIs within our applications and start really diving in to the Android SDK at that time. So until then, thank you all very much for coming, and we'll see you next week.